Okay, upon further review, we are in lesson 5. This is the last day that we are going to be reviewing the foundation, and that's just at the beginning of class. And then we are going to catapult ourselves forward and start working on linear equations. So, without any further ado, let's get a little bit of practice in here. Really drive these points home. These are like some extra reps that we would get in practice. Okay, write an algebraic expression for each phrase. You're going to do stop and start, and then I'll come back with the answers. Okay, so the first one says a number decreased by 92. We're clearly starting with the number, and the order of the terms is extremely important with subtraction. So the number is being decreased, so that's n minus 92. Next one up says the sum of 89 and the number. Now it's interesting with addition. N plus 89, 89 plus n, they are the same thing. Let's just analyze these two real quick. Let's look at the number 1, and let's let n equal 1. And let's look at the answer to the first question. And let's see the big difference. If I substitute a number 1 for n, 1 minus 92 is negative 91. If I do 92 minus 1, that is, I switch the order, I get positive 91. So one of the ways to write it equaled negative 91 and one equaled positive 91. That means the order is very important with subtraction. That makes sense for those who remember, because subtraction is not commutative. The big thing to remember there is that order is very important with subtraction. Order is really not that important with addition, because if I do the sum of 89 and a number, then I could do the answer, which I put n plus 89, which is kind of out of order because the 89 goes first here. 1 plus 89 is 90. But if I do 89 plus n, or 1, I also get 90. So with addition, it's really not a big deal, and you can get a little away with it, but you can't get away with it in subtraction. And sometimes people get a little careless because they can get away with it in addition. Remember, we really tried to emphasize the importance of order with subtraction when we did two things. We did more than, less than, and we said the last shall be first, first shall be last. And then also from goes first whenever we subtract something from something, okay? A number added to 36. I could say 36 plus n, but I really like that n in front in terms of keeping things orderly, so n plus 36. The sum of a number and 26 would be n plus 26. The difference between 46 and the number, that has a very specific order here. The difference between 46 and the number. So you're starting with the 46, and it is subtraction, so the order is very important. 46 minus n. The sum of a number and 43. Again, sum means to add, so this is n plus 43. Quotient, order is also important in quotient. Subtraction and quotient, the inverse operations, are where you will find order to be very important. Quotient of 20 and a number would be 20 over n. Remember, the quotient of 20 and the number. So you're starting with the 20. A number increased by 65. You're starting with a number, you're increasing by 65. Could you have written 65 plus n? Absolutely. You'd get full credit for it. But we do a lot of stuff that's multiple choice. And if you do that, I think you're not going to see 65 plus n very often. You will see n plus 65 a lot. Okay, the sum of 70 and a number, n plus 70. We've been over the order now several times, so I won't belabor the point. A number increased by 18, n plus 18. 55 times a number, 55n. 14 times a number. Well, if you didn't understand 55n, maybe now we adjust your answer to this one. If 55 times n is 55n, 14 times n would be, or 14 times a number would be 14n. Remember, no symbol between two things, like 55n, 14n, that means multiply. A number increased by 65, n plus 65. The sum of 52 and the number, n plus 52. Again, we've talked about order. And 75 more than a number. More than, last shall be first, first shall be last, n plus 75. All right, so that would be the first page. Now let's evaluate each if y is equal to 3. Okay, so we're going to do the first one only. Stop and start. Okay, if I do the first one and I substitute in a 3 for y, the tricky part of this is make sure that you do what's in the parentheses first and that you square the y before you multiply. You see that step there where I take the 3 squared and I make it 9? You got to do that before you do the negative 2 times, okay? And when you do that, it works out to negative 30. That's really the big place kids might go wrong. Let's try the next problem. Go ahead. Okay. This time we have to make sure that we do the multiplication in the parentheses to 3 times 3, which is 9. And if you carry that through, you get negative 54. I'm sure you can look at the steps there that are written before you. Next one, be very, very careful. We got a danger moment here. We're looking for that y squared before we multiply, and then we multiply at the end also. So this kind of combines where you might have made mistakes in the first 2 problems. Go ahead. Okay, this one's pretty long written out. Notice the first thing I do here is square the 3 to get 9. And then I can do the multiplications. Negative 3 times 9 is negative 27. 2 times 3 is 6. I still have to finish off what's in the parentheses and add to get negative 21. And then I can multiply all 3 of them to get negative 189. Okay, let's try this last one. Okay, do what's in the parentheses first. Negative 3 and 4 is 1. And then negative 3 times 1 is negative 3. Now the next one is for when y equals negative 4. And what I'm really trying to emphasize with everybody is the importance of whenever you have a negative number, putting it in parentheses. Okay? When you put it in the calculator, it's extremely important. If you don't do that, sometimes the calculator misinterprets what you're looking to have it do. It doesn't get things wrong. It's just that it has to be clear that you're telling it to operate on the whole negative number, not operate on the number then negate it. Okay. So here's a pretty straightforward one, just substituting negative 4 for y. Do what's in the parentheses first. 2 times negative 4 is negative 8 plus 5. You got to add those next there in the parentheses. That gives me negative 3 here at the end. And then multiply straight across. 3 times negative 4 times negative 3 is 36. Of course, I'm showing these steps out, and all you have to do is put it in the parentheses like it would say in the first step of any of these problems. Just make sure you put parentheses around anything negative. Like on this one, 2 times parentheses 4y squared plus 2y parentheses. Go ahead. Okay. This is where really putting the parentheses around the negative is super critical. If you don't do it, you'll have a problem. Namely, when you put the parentheses around this negative 4, the calculator will correctly interpret it to be 16. If you don't do that, it'll think of it as a negative 16. So then you keep working it on through. Doing the 4 times 16, you get 64. 2 times negative 4 is negative 8. And then we get 64 minus 8 is 56 times 2. That's 112. The big thing that you're going to get here is you're either going to put this into the calculator and be very, careful, as Elmer Fudd would say when he's hunting a rabbit season. Very important to put negatives in parentheses sign. And the other thing that you have to be able to do is answer a question like, which operation would you do first? So for instance, on the next one, we might ask you in a multiple choice, which operation would you do first? And you would have to say that you would cube the y first. Parentheses is not an operation. So it's inside the parentheses that you do whatever operation it says to do, okay? So you would cube the y first. And speaking of the last one, let's put it in there. I cube the negative 4, I get negative 64. Negative 64 plus 3 is negative 61. And then 4 times negative 61 is negative 246. If you happen to forget the parentheses on that one, and you said, well, I still got the same answer and I forgot the parentheses. That's true on all odd exponents, okay? But it's not true on positive, even exponents. On even exponents, you would always get a positive answer out of the deal. And with a negative exponent, your answer would have been negative anyway. Okay, one last problem to do before we finish up our upon further review. Let's do a little stop and start here. Okay, so I substitute the values in, and it's at this point that you could just put it in the calculator and the correct answer will appear. Notice the importance of the parentheses around the -3 by the D. Okay, that gives me this. I'm working things out. I did the exponent next, which -3 squared is 9. Now I do some multiplications. 2 times 8 is, I did the operation in the parentheses, which is -1. Then I did the multiplications, which 2 times 8 is 16, and 4 times -1 is -4. And then, very important here, we just go left to right because addition and subtraction have the same priority. So 7 minus -2 is 9, plus 16 minus 4. And 9 and 16 are 25 minus 4, and that gives me 21. So there's a nice review of lots and lots of stuff that we've done with evaluating order of operations, translating algebraic expressions.